Okay, so the next we will have Patrik from Needronix. Over to you.
Thank you.
Good afternoon. Can you see my presentation?
We do. Go ahead.
Great, thank you. So good afternoon. Thank you for having me. My name is Patrik Laszlo, and I am the project manager at Needronix, and we provide high-tech components for spacecraft. So Needronix is a family company based in Slovakia and Czech Republic. We specialize in design and development of radio and sensoric systems for spacecraft, and we also do CubeSat integration. As a company, we have a lot of experience, and a lot of that experience comes from having 3 ESA projects. 2 as a prime contractor and 1 as a subcontractor to support education with Slovak University of Technology. I would like to take you through our products that could be beneficial for companies building satellites in the Gulf region. I would like to go through our sun sensors, which are our flagship products, through transceiver, earth sensor, onboard computer, and a core sun sensor. So Eagle is our flagship product. It's a power-efficient miniature sun sensor with great performance in a compact design. It has various smart functions, like it can measure its own temperature, and we also provide it with a sensor simulator which can be bought, so that's great for developers so they can test it while they work on the satellite. It has fast lead time. It has flight heritage since 2017. It's very light and it's very precise with low angular noise at 0.09 degrees at 1 Hertz. It's actually 43% smaller by volume compared to the industry leader. And actually, it's highly likely that our sun sensor is the smallest in the world, and it's an essential component of a satellite. And also, compared to the industry leader, we have 1/6 of the power consumption under workload. As we know, saving space in satellite is extremely important, mainly for the payload. There is a lot of underutilized space, like perhaps the sides of the satellite. So what's absolutely great is that Eagle can fit between the solar panels of a satellite. It's suitable for accurate sun position determination, CubeSat attitude determination, CubeSat solar panel positioning, and it can be used on nanosatellites, suborbital rockets, balloons, or UAVs, but it was mainly designed with CubeSats in mind. What's actually interesting is that this component, along with another component I will shortly tell you about, was used in a CubeSat mission GRB Alpha, which was a 1U CubeSat, and it was a scientifically important mission because it was the first CubeSat to detect gamma ray burst, and the data was used even by NASA. Another component, our brand new Earth sensor, sun sensor, is Eagle Plus. It's also dual axis fine sun sensor. This one has inherited flight heritage from the Eagle I showed you previously. It's also very lightweight, very small, and this one is even more precise with 0.002 degrees at 1 Hertz. It's actually so precise that we were able to measure angular speed of Earth's rotation with it. And it's very fast. It can do 166 measurements per second. This one uses RS 485 bus. The previous Eagle uses I2C. And this one also has a very interesting function, sample and hold, so they can do a snapshot and you can read the data later. Another interesting product also used in the GRB Alpha mission is Cormorant. It's a CubeSat transceiver. It's also very small. Frequency range is from VHF to UHF. It has flight heritage since 2021. It also has very low power consumption. It has a CSP packet router, so you can route CSP packets between other buses. It has M-radio digipeater and what we call DNxD, which is a delayed digipeater, which we created here at Needronix, so you can delay the sending of a message. It also has battery monitor, and as all our components, is also very easy to integrate. Another great thing about it is that you can actually fit two cormorants on one PC104 board. It's great for redundancy. One can work as an uplink and the other can do downlink. And if for some reason or something happens to one of them, they can be reconfigured in space. So one does both uplink and downlink. Our next product is Osprey. It's a miniature Earth sensor and provides you with pitch and roll determination, Earth, Sun, and Moon detection. It can also do albedo identification for other subsystems, so they also work great with sun sensors. Their main benefit is usage in Earth's shade, where a sun sensor might not be ideal. And it's great for Earth observation missions and can also do Earth thermal imaging. There's very wide field of view, low power consumption, and exceptional accuracy. And another component is Sparrow. It's a navigation computer. It's an alternative to GNSS solution if you don't need a really precise time source. It also provides real-time satellite position. It simulates NMEA GNSS messages, so you don't need to configure the software of your onboard computer. Benefit is that you do not need any external antennas, so you save some space on the surface of the satellite, perhaps for another solar panel. Sparrow uses CubeSat space protocol for communication, has very low power consumption, and you can actually fit 4 of these on the PC104 board, and each of them can be configured to do different things. Like one can function as a navigation computer, another one can work with the satellite data and whatever you want to do. And in collaboration with ESA, we are working on another sun sensor. This one is for larger satellites on geostationary orbit with lifetime of more than 15 years. It's robust, it's human failure resistant, it has no power consumption because it's passive. It's pyramidal sun sensor, and there are actually two independent sun sensors in one case, and it's great for safe mode operations and detumbling. As a company, we were part of 8 missions, and we have 5 upcoming missions as a work in progress. And to highlight some of the missions we participated in as a company, our first main mission was the skCUBE CubeSat. It was the first Slovak satellite. We developed the first version of Eagle for it, our sun sensor. We also developed the antenna system and software for power source unit, and we participated in design integration. And already mentioned scientifically important GRB Alpha mission. We supplied the NX-SS3 Eagle sun sensors, our transceiver cormorant, and we also participated in the design integration. And we also participated on the mission VZW-SAT-2, which is a Czech CubeSat. We also supplied NX-SS3 Eagle sun sensors and RF coaxial assemblies. As a company, we also have our own ground station, NXGS. It has VHF and UHF uplink and downlink, and we also supplied components to more Czech, Polish, and Italian missions. As a company, we have a lot of partners across the industry, from private companies to universities. So thank you for your attention.
Patrik, thank you for your time and really nice presentation. I would really highlight the visuals. It was really neat and clean. Thank you very much.